I wanted to take a little bit of time to cover some of the concepts that will be on the test that covers Ansi, Ascii, and binary. And if you look in your course site's website, yours will look a little different than mine because you don't have some of the menu options that I have. But if you come to your home page and you go to More Announcements, and if you scroll down to Friday's announcement, you will see everything you need in one place as far as links to go back and watch the videos to prepare for the test. So one of the first things I want to talk about is Ansi, which is the American National Standards Institute. Believe it or not, they were founded around 1918 with the idea of creating standards for various things way before computers came along. And my understanding is that when computer technology came along, Ansi is a nonprofit organization, and various companies like IBM, Microsoft, Oracle, the major players in the software development and relational database industry, they all voluntarily participate with Ansi, and they agree to certain common denominators. Sorry, I'm losing my voice. Certain common things that, whether you're using an Oracle database or a SQL Server database or a MySQL database, all those folks will come together and say, okay, we all agree that, for example, a select statement will be written a certain way. We all agree that certain things will work the same no matter which company's product you're using. And then each company is free to go off and develop extensions and things that are unique to their product. But if you think about it, the good thing about that for customers, businesses, government organizations, anybody that's going to use a database, any developer, you learn ANSI standard SQL, and it doesn't matter whether you work in Oracle or SQL Server or any other database. As long as that database conforms to the ANSI standard, you know 90% of what you need to know in order to do your job without having to learn proprietary or specialized languages. And so one of the things that ANSI, the ANSI Standards Board, does, they also get Microsoft and other companies together, and they'll say, okay, the language C++, we're all going to agree that a print statement will work the same no matter whether it's Borland's compiler. Borland used to be a company, I don't know if they're still around, or if it's Microsoft's compiler or some other company's compiler. We all have our own compilers for the C language, and we all agree that a print line will work the same way, an if statement will work the same way, a loop will work the same way. There'll be common things so that if somebody's programming in Microsoft C and they change jobs and go to a place that uses Borland C, they don't have to relearn everything. They know the basics of the language. Now, each compiler might have 10% of their product that has some bells and whistles that's unique to them, such as Visual Studio has a very nice interface compared to some of the other compilers and has some extra features that they don't have. But overall, we're saying that there's a basic standard so that programmers learn the ANSI standard version of a language, and then it doesn't matter which version, whether it's Microsoft's or some other companies that they're working in. One of the big contributions of Ansi was to come up with a standard code for all of the letters, numbers, and symbols that you could use when using a computer. So in the very early days of computing, you had Tandy Radio Shack making a computer, IBM was making computers, different companies were making computers, and they all had an operating system. IBM was using something they created called OS2. and you had windows and all of that. So there was the potential for a situation where the Tandy company decided that, the number 35 was going to represent a capital A, and then it would get translated to binary and stored on the hard drive. And then maybe IBM said the number 42 in their character set was going to represent a capital A, which would get translated to binary and stored on their hard drive. Well, the problem with that is if you wanted to share files, you did a Word document, word processing document on an IBM machine, and then you put it on some type of a disk and you took it to the Tandy machine. The Tandy machine had totally different codes for the letters. It would just be garbled and garbage. So now you had the potential for, if IBM gets most of the market share and some little company is using Tandy and their bank is using an IBM machine and they need to share data, they can't do it. So in order to prevent that, Ansi sort of came up with the idea that since we know that every character that is stored on the hard drive has to be numeric, there are no letters and numbers and symbols. If you could take a magnifying glass and actually look at the actual tracks on the hard drive on your computer, you would not see letters, numbers, and symbols. All you would see is ones and zeros. You would see binary. So we know that everything has to equate down to a number. So Ansi kind of came up with this Ascii code, which is a translation table that everybody agreed to use. Everybody agreed a certain letter would represent a capital A, a certain letter would represent a certain number would represent a small a, and so on. So that it didn't matter if you're using a Tandy Radio Shack computer or an IBM computer or some third party's computer operating system, didn't matter if you were using OS2 or Windows, you could take a document from one computer and take it to a different manufacturer's computer with a different operating system, and the document would still be readable. It would be as it was supposed to be. So we have the idea that we have a nonprofit group called Ansi, which is the American National Standards Group, or the American National Standard Institute, rather. So we have this nonprofit organization whose goal is to make things standardized for the benefit of you and me and little businesses, that they make the big guys come together and agree on things so that there's a standard, so that you're not tied. You don't buy an IBM machine and then you can never change from IBM, or you lose all your data, for example. So they kind of leveled the playing field. And so in order to prevent IBM from saying, well, I'm going to use this character set, and then Tandy says I'm going to use a different one, and then the customers are kind of caught in the middle. You can't take a document from one machine to another and all of that kind of stuff. They brought all the players in the early days of computing together and said, let's come up with a translation table whereby we take every letter, number, and symbol on the keyboard, and we decide which number, which decimal number it's going to be represented by, and then later on, it gets translated to binary and stored. So they came up with the American Standard Code for Information Interchange, or ASCII. And you can Google and find the whole chart. We're just going to kind of scan through here and look at this. Ignore everything that says hex on there. We're not doing hexadecimal. That's a whole other topic. So here is the decimal number, the number you're used to, 32. And you really don't have to worry about what that means in HTML. But the number 32 is a space. So every time you hit the space bar in a Word document behind the scenes, you don't realize it. Because remember, the computer deals with numbers, not letters or symbols. But every time you hit the space behind the scenes in your Word document, hidden from view, the number 32 gets written to that file. Every time you type an exclamation point, you see an exclamation point, Word translates it to the number 33 and hides that from you behind the scenes. And so you can see, for example, a percent sign is represented by the number 37 and so on. So here we've got all of our basic punctuation translated. And believe it or not, the numbers, for example, the number 9 is not represented by 9. In Ascii, it is actually 57. So if you type the number 9 on your keyboard in Word or whatever you're using, whatever program software you're using behind the scenes to save the 9, it translates that to a 57. Now Word knows when it opens a document it sees a 57. For you to understand what that means, it turns it into the number 9. You see the number 9. But really written to your hard drive is a 57. Then for the letters, which are really pretty important, probably the most important thing, capital A, all of the capital letters from A to Z, we start at 65. So if you type a capital A, 65 gets stored behind the scenes in the file that you're saving in Word, and that gets translated to the binary equivalent of 65 and written to the hard drive. Then when you open that file back up, Word is smart enough to see the binary representation of 65, realize it's the decimal number 65, and display for you the capital letter A. Then the lowercase letters are all grouped together. They start at 97, and we go all the way down to 122. And then every other character pretty much that's on the keyboard is represented here. As you can see, I'm not all that worried about anything other than letters, numbers, and a few punctuation marks. But you can see they are all represented by by numbers that then get turned into binary, and that's what gets stored on your hard drive. So the relationship is the American National Standards Institute brings together, and it's not just computing, it's all kinds of industries, manufacturing and so on, automotive, whatever. They bring everybody together and they come up with some baseline standards. Every computer is going to save the capital letter A. Oops, I passed it. As the number 65. Everybody agrees on that. They agree to everything in here, which means whether I'm using an Acer computer or a Chromebook or a Windows machine or Linux, whatever I'm doing, I can take files from one machine to another, despite the fact that they've got different manufacturers and different operating systems, and I can open that file and it will be the correct contents. It will display correctly and show me the same information no matter what. So the ANSI standard board brings together everybody, and all the manufacturers at the time and the big players in computing history way back in the day decided to create this translation table called ASCII, the American Standard Code for Information Interchange, so that everybody could share or interchange information. So that's the relationship between ANSI and ASCII, and we know, as I've talked about, nothing on the hard drive is stored in anything other than numeric format. You would never look at your hard drive and see the capital letter A written to the drive if you got a magnifying glass out and you could actually see what was written on the hard drive. All you would see is zeros and ones, binary. So to make it easier on us when we're looking at an ASCII table and we're programming at a very low level, you would never do this, but there are programmers that would. If they needed to take save an exclamation point, they would know to put it as a 33. And then the operating system of the computer or the software on the computer will figure out how to turn that 33 into the binary equivalent with zeros and ones of 33, thus saving the exclamation point. So you can see there's translation that goes on because a computer really understands only two things, zeros and ones, on and off, more or less. So that's kind of a wrap up as you prepare for the test to explain ANSI and ASCII and the relationship to binary.